Hello, learners. Welcome back to All About Java, a beginner's guide to learning Java programming with me, Apurva Barve. So far, in the lecture series, we have written our first program and executed it, understood the syntax of a class, method, and main method, and we have discussed the decision making statements in Java. With each lesson, we are getting to know something more about the language. So, what are we going to do today? In today's video, we are going to talk about the coding constructs in Java. Then we will learn about the atomic elements in Java. We will discuss the data types, the primitive data types to be very specific, and understand when can we use which one. And because we have come as far as data types, we have to end this discussion with type conversion. So, why wait? Let's deep dive. When we write a program, we need to write more than one code statements. Mostly, we group related statements into a single unit. This single unit is called as a code block. The scope of the code block is marked by open close curly brackets. And there's no limit to as many statements as you want to have in the code block. There's no upper limit to that. In fact, you could even have a code block with no statement at all. These blocks could be named or unnamed. In case the code block is unnamed, it is called as an anonymous block. We have seen such blocks as a part of our if-else example and when we wrote switch statements and switch expressions in the last video. We will be seeing such blocks when we do more of for and while loops, when we write our business methods, when we do constructors, when we write a class or an interface. In fact, in Java, this is the highest level of code block. And we will also see the code blocks when we do static blocks. So, everything that you want the program to do is put in one or many such code blocks within the program. In addition to the code blocks, the atomic elements within Java help in completing the code. Java recognizes some predefined elements which are termed as atomic. These elements are white space, identifiers, literals, comments, and separators. Let's take a look at individual category to understand what do we mean by each one of them and how do we use them while writing our code. White space is because Java is a free form language, which also means that you could write your entire program without any indentation in a single line, provided it is separated by the right elements. In Java, the white space includes a tab, which is to introduce indentation if you want to, a space bar, new line character, or form feed. These spaces make the code more readable and do not interfere with the code statements. The next kind of atomic element are the identifiers. Now, identifiers are used as the names which are given to classes or variables or methods. Java, being a case-sensitive language, some identifiers should start with an uppercase letter, while some start with a lowercase letter, and there's a distinct difference between these. Here are some examples of which kind of identifiers are allowed. So here if you see, the first one starts with a capital letter, uppercase, this is allowed. The next example starts with a lowercase letter. This too is allowed. The third example consists of three words which are separated by the underscore. This is allowed. The fourth kind is where we have a combination of characters and digits. This too is allowed, provided the name starts with a character, an alphabet. And the final example is where I am starting the name of an identifier with a dollar sign. Dollar sign identifier has a special meaning, specific meaning, and they should be used only if absolutely necessary. Otherwise, we can use any of the other allowed ways of labeling an identifier. And while we are talking about those that are allowed, let us also take a look at what is not allowed by the language. Here, the first identifier begins with a digit, and that is why it is not allowed in Java. The next has the slash, the forward slash, so such kind of characters are not allowed when you label an identifier. And the other one has an hyphen symbol. This again is not allowed in Java. So you have to take special care while labeling your identifiers, while choosing your identifiers. And you also have to remember that Java is a case sensitive language. Typically, when identifiers are used to name variables, they start with a small letter, a small first letter, and they follow camel casing. And when identifiers are used to label classes and interfaces, they start with a capital letter. All right, let's go over to the next category of atomic elements, which are the literals. Now, when we say we have an identifier, the identifier is the name given to the variable, and literal is the value given to it. So, very easily put, the value that any variable will hold is the literal. Again, there are some rules in the language pertaining to the literals. These are some examples. This is a numeric value, complete numeric value, which will be stored as a number. This being in double quotes is a string. Now, this is how Java identifies a string from a character. ST is a character and it is put in single quotes, whereas ABC is a string and so it is put in double quotation marks. Anything that comes in double quotation marks within Java is a string, and anything that is in single quotation marks is a character. The next is the constant value which is used as a Boolean value. So true or false, lowercase t or lowercase f will indicate the Boolean value given to a Boolean variable. And the next one, the final one, is a value with a decimal point, a decimal value. So as you can see, Java allows all the possible kind of values to be put into the corresponding identifiers. Now let us talk about the comments. When we did our first program, we have spent enough time in understanding what are the different types of comments that are allowed by Java. As we know, the first one in that is a single line comment. A single line comment starts with double forward slashes and it has to end in the same line. That is what makes it a single line comment. The next one is a multi-line comment, which starts with a forward slash and an asterisk mark, goes on to more than one lines, and ends with an asterisk mark and a forward slash. Multi-line comments were also covered in our example in the first program of Java. You can revisit that video and check out the syntactical way of putting these comments. And the last type of comments that are allowed by Java are the documentation comments. These documentation comments are used to produce an HTML file that documents your program. They hold the Javadoc tags such as author, return, etc. We did this as well in this first program of Java that we covered. So once again, you can go and check that program. Typically, the documentation comments are slightly different from the multi-line comment, wherein they have the forward slash and double asterisk in the first line with the same notation used for the same that is used in the multi-line comment. And finally, it ends with an asterisk and a forward slash. So these are the three types of comments that are allowed in Java. Comments are ignored by the compiler, but they contribute significantly to the readability of the program. So every good programmer should inculcate a practice of adding comments in the code in order to make the code more readable to himself or herself, as well as to anybody else who could be reading the code later. Finally, we have the separators. There is a long list of separators, and let us take a look at these category wise. So, the first kind of separators are those that help in segregating your code. All right. So, we have the parenthesis. We have seen parentheses when we were doing our if else condition and when we did our method syntax. So, parentheses hold the parameters and are used to set the precedence. Next are the braces. So we know that curly braces are going to inform us or tell us about the scope of the code block, a class, an interface, a method, a loop, if statement, switch statement. They basically deal with the scope. Finally, we have the brackets. Brackets are used to declare array types and referencing array elements. We have seen this actually when we wrote our main method. In the main method signature, we have array and we have seen this element there. The next set of separators are the semicolon and the comma. Semicolon terminates the code statement. So I said at the beginning of this video that I can write the entire Java program in a single line provided the lines are separated by the semicolon. The moment the compiler comes across a semicolon, it knows that it has to end the code statement there at that point. Comma, on the other hand, is used to separate more than one identifiers. We will use this when we write our for loop. So it is used to separate those identifiers. And it is also used to change statements in the for loop. So that is where we see a comma coming into our code. Finally, the next set of separators, which in the beginning has the period or dot operator. When we do more of object, class, and creation of object, we will, and writing our methods, we will use the dot operator extensively that time. We also used this when we were adding a package to our class. So when we said java.lang or java.util, we added, we separated the package names using the dot operator. Then we have the colons. The double colons here are used to create method or constructor reference. Again, we will have to wait for the implementation of this, syntactical implementation of this, till we go a little further in our lecture series. And finally, we have these three dots. These three dots are called as ellipses, and they are used for whereas syntax if we want to have it in Java. Once again, we will have to wait for a little while before we actually start using them easily, comfortably in our program. However, these are the atomic elements in Java. We will use them knowingly, unknowingly, and as a matter of habit when we start coding better examples in Java. Finally, we have the at the rate sign. We saw this sign when we added Java doc in our first Java example. These signs are also used to indicate annotations. So, This is the last separator that we have in the list of separators. And this also takes us to the next slide, which is about the data types. We spoke about the identifiers, where we said identifiers are the names that we give to the variables. Then we spoke about the literals and said literals are the values that the variables store in themselves. Data types are the categories of these variables. We saw that Java allows a variety of literals. So we have strings, characters, Boolean values, complete integers, decimal numbers. We have so many different variety of information, so many different variety of data supported by the language. Data types help us in labeling or categorizing the identifiers depending on what they will be able to store. Let's understand this. All the data types that we will be doing now are the primitive data types which are ready-made in Java. Let's see which are these. The first ones are the integer types, which will be used to store whole valued numbers. So 10, 5, 100 whole number values will be stored using integer types, and decimal number values will be stored using floating types. Integer types in turn have byte, which is the smallest integer type. It is a signed 8-bit type and it ranges from minus 128 to 127. And this is how you declare a byte variable. So if you have a very small numeric value that you would want to store, you can consider using byte data type for that variable. The next one is short. Now, short is 16-bit type, and this is the range for a short variable. And this is how you actually declare a variable. Once again, if you have a value which is little more than byte, a numeric value, but not very large, you can consider using short data type. And then we have a very famous data type, int. We tend to use this commonly if we have to store any integer value. It is a 32-bit type, and when byte and short values are used in an expression, they are promoted to int whenever the expression is evaluated. We will talk about this when we come to type conversions. But whatever are these values, so byte, short, int, they are similar data types. They all are integer data types, and there is an easy conversion between the data types that are similar to each other. This is a syntax of declaring an int variable. So you have the data type, you have the identifier followed by an equal to sign and the literal. So this is pretty much how we declare variables. If you have a bigger value than int, you can consider using long data type for it. As you can see, it is a signed 64-bit type, and it is used when int type is not large enough to save your numeric data. And this is how I declare my long variable. So if I have miles or distances to store, maybe then I would want to use long data type, because int will not be sufficient, short byte will not be sufficient. So these are my integer type values. Now let me understand what are the floating point options given to me by Java. So Java gives me two floating point data types. One of them is float. So float is again a 32-bit type, and it is used when a fractional when you want to store a fractional component but don't require a lot of precision in that component. And typically this is how you use a float variable, a float data type in while declaring the variable. But you have to take care that when you declare the variable of float type, the value of the variable has to be followed with small f character. So that is one overhead of using float, but you can use it if you do not really need the values to be very precise to the last decimal value. The other alternative that you have to for storing floating type variables, floating type numbers, is the double data type. Now, double is something, of course, it is a 64-bit type, but it will be used if you want to maintain a higher accuracy while storing your decimal values, or if you're manipulating large valued numbers. So maybe pi or sine value, something like that, where the precision matters, where you should consider storing it using double data type. So basically, all these byte, short, int, long, float, double, they all cater towards numeric data. Let's go on forward and understand how do we store other type of data. Char type and booleans. Within char, you have the char data type. The char data type, it is used for storing characters in the Unicode format. So if you want to do the kind of programs where you want to identify which key was pressed by the user, or if you want to convert a given string into a capital case or lower case, you want to do it manually. That is when you actually need to know the Unicode format of the characters, and char stores the characters in that format. So if I say char ch is equal to 88, this 88 corresponds to the Unicode letter assigned in that format. Again, if I say char st is equal to a, then a can also be read using its ASCII value. So this is something that can come handy if you want to manipulate the characters, understand them, or read their ASCII value. You can use char to represent that data. It is a 16-bit type. Boolean, as you can see, it is to hold true or false value. When we did if statement, we said that every condition that you put within if is evaluated for its Boolean value. So these are the values that we were talking about. So either the statement will evaluate to true or the statement will evaluate to false, and that is how the flow of the if condition will be decided. Similarly, we can also have Boolean variables. Boolean variables, they mostly are the results that are coming in, and this is how you declare them. So you have the name of the data type, the variable, that is the identifier, and the value. Value could either be true or false. If you do not give any value, then it is by default declared as false. All right. So these were some primitive data types that we have in Java. All these data types will be used somewhere or the other when we want our program to capture some data, hold some data, process some data. We are going to use them very often as we progress with our code, as we progress with our examples and the understanding of the language. But because we are talking about data types and we said that if the data type is similar, then it is easy for the compiler to convert one data type to another, then let us discuss about type conversions. Type conversions is, very simply put, converting a value from one type into another. How does Java achieve it? Java achieves it in two ways. One of them is the automatic conversions. Automatic conversions are between two compatible types. So it could be either int type, or it could be the numeric types, or they could be floating types, or they could be character types. So they are between compatible types. This is the first requirement of automatic conversions. The destination type is larger than the source type. This is the second requirement of automatic conversion. So if I'm converting one value from X type into Y type has to be larger so that it can easily accommodate X type, and there will be an automatic or implicit conversion. And because the larger the final data type is the larger one, we say this is a widening conversion. Some examples, let's say I have x is equal to 10 and I have long y variable. I can very easily say y is equal to 10. In this case, the int value 10 is easily converted into a wider, larger variable y, which belongs to the data type long. So this is a widening conversion, an automatic conversion happening within the language without any additional efforts. The other type of type conversion is called as casting. Now, casting is when we are trying to convert or we are trying to deal with incompatible data types. Will ever be a situation like this? Yes, plenty of times. Plenty of times we need to convert incompatible, non-matching data types, one data type into another. So yes, it is a realistic situation. We might have to deal with something like this sometime during the course of our programs. So whenever we are doing that, we are trying to achieve casting. Casting is a narrowing conversion. The moment we say that these are incompatible, it also means we will need to tweak the values that are getting converted, and it is always a narrowing conversion. Let's take an example. Let's say I have an integer value x, which is given 10 as its value, as the literal, and I have b variable, which is of the type byte, and I say b is equal to x. Now, byte being a smaller data type as compared to x, which is an int data type, which is a bigger data type. I'm trying to fit in a bigger value into a smaller data type. I need to explicitly write this byte into the parenthesis to instruct my compiler to perform the narrowing. This is where casting is put into the picture. If I take a look at the previous example, there was no casting because this was automatic conversion, easy conversion, smaller value getting into bigger space. My compiler was happy doing that. But here, there is a bigger value getting into a smaller space. So I need to push for this casting. And this is where it is a typecast example. So this is a narrowing conversion, but both these conversions, automatic or casting, both these type of conversions are supported by the language. All right, let's consider an example. So I have a variable x declared as int having value 10. I have another variable y declared as float having the value 12.50. And as we said, because it is a float variable, it has to end the value with the letter f. Then I have a double variable z given the value 13.75. And then I have a char variable c having the value a. Now, because it is a char, it is enclosed in single quotes. And finally, I have another double variable result, which is initialized to the value 0.0. These are my variable declarations. Now, what happens is I am assigning or I'm carrying out a code statement here which has got multiple parts and which are separated. Every part is separated by a set of parentheses. The very first thing that will be evaluated will be this bracket or this parenthesis using the BODMAS rule, of course. So it is going to be this part of the expression which will be evaluated first. X will be auto promoted to the float data type. Now let's take a look at x, which is of the type int, and y, which is of the type float. I want to add these two variables. So x will be auto converted to becoming a float. So internally its value will become 10.0, and then it will be added to 12.50, and then this whole expression will be evaluated. The next thing to get evaluated will be z plus c. Again, z is double and c is char. Here, the char value, which is the smaller value, will be promoted to a bigger value, z, and then it is going to be evaluated. Now, how will this be promoted? I said that Char stores its values using Unicode format. So the ASCII code of A will be assigned to C, and that is the numeric value which C will continue to have, and that will be added to Z. So that is how this part of the expression will be performed. Finally, we have this part evaluated, we have the other part evaluated. Both the parts will be multiplied to each other, and that is how I will get my result. Result is of the type double. So I'm going to have the double variable result getting its final value in the double format. So if you see, I have int, I have float, I have double, and I have char type of variables which were auto promoted. This is type promotion. And finally, I print the result. Learners, this brings us to the end of lesson 6. If you have been following the lecture series properly, then by this point, you should be able to write a simple class, add some business methods, having variables, print the variables using system.out.println, add a main method to your class, and you should be able to execute the main method and even invoke the business method by creating objects. In the next video, we are going to understand what is a variable, what are the different types of variables in Java, and how does Java treat its variable. Till then, thank you for watching these video series lectures. Please show your love and appreciation towards the lecture series by liking, sharing, and subscribing to our channel, Ashwas. Thank you so much.